All right, so we want to make attack work. Um, I wanted to start with these getters as a way for you to see the self variable entirely on its own. The attack functionality is going to have us practice working within a class with all these different variables available to us. And more importantly, how do I distinguish variables that are part of me versus part of another object that looks exactly like me but is not me? So again, comparing your resume to that of somebody else. You both are students, you both are applying for a job, but what qualifications do you have versus what do they have, for example? So the test here has a whole bunch of different tests for that, but let's just kind of build this logically speaking out based off the rules we saw before. So the game rules class over here, game rules, has a bunch of variables set up pretending like they're constants. Again, they don't have constants in Python, but this works well enough for us. So this class just simply holds data that helps describe the game rules. So our game has red and blue players. We have outcomes that we're going to return back. So either the attacker's going to win, the defender's going to win, there's going to be tie or nonsense, and then there's all the different players that can win. And so the most basic rule we could say is that if my rank is higher than your rank, I win, or vice versa. So I'm inside the attack function now. I want to compare my rank to your rank. So if my rank, so what is my rank? Well, it's self.rank. And if my rank is, in this case, it's actually going to be less than your rank because the lesser rank, the way I've set up these numbers is the stronger rank. So if my rank is less than other piece, so I'm a piece, I'm attacking another piece that also has a rank. So notice I could call get rank. Nothing wrong with that. I can also directly access the other piece's rank because I am inside the same class as the other piece. So whichever one is more logical for you. You could say self.rank or you could say self.getRank. You can say other piece.rank or you can say other piece.getRank. When all it does is access a variable, there's literally no difference whatsoever. When there's other functionality, I call it based off of whether I want the raw data or whatever comes out processed from the other functionality. So in this case, either one will work. But when my rank is lower than the other piece's rank, then I win. So I'm going to say return game rules dot attacker wins. So in this case, notice I can go to game rules and I can get that variable directly out of it. Now, this has a different connotation than self. Bomb, marshal, general, all those things are called global data in object orientation because they're part of the class, but they're not part of an object. They're true for all game rules, not just one specific instance of game rules. So each piece has its own name. Each piece has its own rank. Each piece has its own color. More importantly, a combination of the three of them. I could have more than one of a type of piece out there at the same color and the same rank. I could have many, many pieces of different ranks, and each color has all the same pieces, but we all share the same game rule. So notice the difference here between the self and accessing a value through the class as a whole. This is going to be true for everybody where the rank is going to be different for each piece. So let me just add a little bit more logic. Otherwise, elif, excuse me, because there's one other situation. The self, if my rank is greater than, if I'm a lower rank than the other piece, then I'm going to return game rules dot defender wins. And then I have the else. If it's not greater than, if it's not less than, then it must be equal to, which means I can say return game rules dot tie. So that's not everything. But let me just down here, let me change none to be game rules dot nonsense because I shouldn't get here at all. right? I'm either going to be greater than or less than or equal to, and so I should get one of these three situations. Now, this isn't everything, but it's a start. And hopefully I'm showing you a start where I can access my data, another object that happens to be in the same class as me's data, or not attributes. Not attribute data. All three of them I get to see right here in this little simple little example. But let me save my class here. I could run it, not going to do anything. It saves it, but it doesn't actually do anything because I have no tester inside this class. So again, I got to get used to this idea of running it in the tester class. All right, so now I've got some errors here. So attack failed. When the attacker wins, the attacker should be true and defender false. But attacker true and defender true. Um, so not entirely sure what this is saying, but that's why I can always go back and look at my test cases, right? So when the attacker wins, the attacker should be true. Defender false and defender false, but the attacker true and defender true. Okay. So if I go look at my test case, um, when the attacker wins, the attacker be true and the defender false. But so is active and is active. Oh, yeah. So there's another requirement inside of here. So this is the brilliant part about objects. So not only am I determining whether the attacker was true or false, which I seem to have gotten in a bunch of scenarios. So we'll come back to this in a second, but if I skip down here, you can see the bomb attacked the marshal and I expected 4, but I returned 1. So when the bomb attacks the marshal, I expect nonsense, number 4, but it returned that the bomb wins. So when the flag attacks the bomb, I expected nonsense. Well, I didn't cover those scenarios. When the spy attacks the marshal, I expected the spy to win, but that's not what happened. I didn't deal with those special cases. But before I deal with those special cases, I have to deal with this other requirement inside of here. So if I go back to my problem description, you can see active. What does active mean? Well, a piece is active when it's placed on the board until a player action removes it, making it inactive. So when you lose a battle as the attacker, as the defender, or because you tied, that piece is no longer active and should be taken from the board. Excuse me. So I need to include that in my model. And the great part about objects is I don't have to have somebody else do that. When I attack another piece, well, if I win, I'm fine, but the other piece dot active should be false. When I attack somebody else and I am a lowercase, the defender wins, then myself dot active is false. When it's a tie, both of us should be false. So not only is the other piece going to be false, but also I'm going to be false. So we can see hopefully here how working in objects, I can give you a result. And in this case, it's very useful to modify the state of the object. I lost. I'm no longer active. I can't be on the board anymore. And being inactive might be the signal for the board to take me off the board. But I'm not going to do that. That's not my job. My job just simply to say, yes, I lost. I'm no longer active, given this design. So I hit F5 there, but I saved that. I'm going to run this again. All right, so now I have much fewer errors. I created some different errors because there's more to objects than just simply returning something in the function. If all I was doing was comparing them, I could have just done it as a function, but I have that other state. But now, again, I haven't dealt with when miners attack bombs, when spies attack marshals, and when bombs and flags attack. So I can deal with those here as well. So let's deal with the last one real quick. So if self dot rank is equal to a game rules dot bomb, or I'm going to do a slash here to keep my code short. Self dot rank is equal to game rules dot flag. Then return game rules dot nonsense. I actually don't need this down here because this is going to return one of these three every single time. So again, if it's a bomb or a flag, it's nonsense. If you haven't seen it before, the slash just simply allows me to put this on the next line. It's required in some cases in Python and not others. It's just based off what they did. Oops, again, I can't run this one. I got to go to my test code and run that one. All right, so now I just have minors and spies to deal with, special cases for minors and spies. So let me come back to my piece. And so now, well, this is good. For general pieces, but we need a special situation. So if if I am a minor, and we'll do a slash again. Oh, not self.rank, but other piece is equal to a bomb. Well, in that case, then I'm going to win, right? Oops. Well, since I'm the winner, I need to actually do the same thing as what I did here. So let me just copy and paste this code right here. All right. So it's just that special case. When I'm the minor and the other piece of the bomb, then I ignore the rule that's going to come up in a second. I can resolve myself right here. Now, notice I copied and pasted those two lines of code. There's a lot of different ways I could do this logic. I could have some variables to say who's the winner and loser and then figure that out later on. I think my choice right now, given everything that's going on, it's just easier to solve that problem and be done with it right there. I think that I'm okay with that, to have that copy and paste. But you should be aware of that. The logic to do setting the active inactive in one spot seems to me right now more complex than just doing it in multiple places. But that's not always the case. And you might not disagree. You might want to do it your logic differently, which is totally fine. So let me just make sure I save this. Let's come back and run this, and let's see if I've dealt with minors and bombs. I have. So now the minor is happy, and we can go from there. And then, fortunately, logic should be pretty straightforward. That if my rank is equal to a spy, and the other piece rank is equal to Marshall, then same thing. The other piece loses and I win. The special rules, not too bad when you come down to it. And as a general strategy, I take out the special rules and then I apply the general rules. It doesn't always work that way, but notice I don't have to have all that inner inside of here. I can kind of deal with that on its own. It's not the prettiest code, but it's also, I don't think, all that difficult, assuming it works. Let's test it. And yep, all my tests passed. So that is the key for working inside of a class. The main thing is remembering the self where needed, or accessing data from the other class as needed, or accessing data from another object that looks just like me but has its own copy of the data. And it's not all that different outside the fact that the variables have the same name. I'm just accessing it from a different place. And I think to some degree it kind of should make sense, because if, for example, we're ordering pizza together, I say, well, what's your favorite pizza? What's my favorite pizza? And then we figure out what the actual pizza we're going to order based off of our favorites, right? There's three different things going on: what you like, what I like, and then what we're actually going to order. And I think this idea, once we translate it into our head about code, once we start thinking in objects, I believe it makes a ton of sense. But it does mean stop thinking about variables as just one size fits all things and start thinking about them as what they represent, what their context is. All right. So have fun tackling these other videos on how to use objects. There might be some other helpers to get you started on some of them, so look for those. But definitely, this is a great complete example to work through, churn in for some points, and use as a setup for the rest of the assignments.